Okay. I don't know why it's so hard for me to be consistent with programming, but I'm trying my best to do it every day. I know I missed yesterday, but it's just like the barrier. It's like since I don't know what I'm programming, it's just daunting to even start because I feel like, what if I can't make enough progress or make a committable difference in our project? But I really just need to drop that and just focus on doing any amount per day, So right now we've got this tween value that we are we're making so that we can determine how far, like, yeah. So like this tween value sets is equal to a number 0 to 1, and 1 being as loud as it can be and 0 being completely silent. We're determining how big that number is based on the character's X position divided by the width of the screen it can fit on. So when it's all the way to the right, it'll be a +1. When it's all the way to the left, it'll be a 0. Now, we don't want the sounds to be triggering just from left to right. We might want one sound like that, but we need to figure out a way to come up with values for not just where it is in relation to the leftmost or rightmost side of the screen, but how close it is to a certain object. So because we want to do these biomes, we want windy to be up at the top. So like the 0 to 100 scale for the wind is somewhere around being at the middle of the screen to all the way up to the top. But we might want to make it get even a bit louder if you go over to the right. So we need to calculate a tween value between, we need a value that can say, if there's an object over here and you're just going up, you're technically getting closer to it. But even if your X's or even if your Y's are aligned, it doesn't mean you're all the way loud because you're still got an X distance. So it's almost like we need to calculate the tween value based on the distance, based on the X and Y distance, right? So if there's a player and a biome, we need to draw a rectangle or draw a triangle, 90 degrees of what our X and Y position is. Calculate, Pythagoras C side of that rectangle, and then tween the value based on how small the hypotenuse is in relation to the biome point. And if we do use of absolute value and stuff, we should be able to figure that out for whether or not the character is down here or over on this side or up here, because up here would be a negative number, or above the screen or whatever. We got to figure out, make sure that hypotenuse logic works for all that. So what would be, how do we say, if the Y's are aligned, then it's just the X position, but we want it, how am I trying to say this? Like if we're doing that tween value based on the hypotenuse, if both our player and our biome are at the same Y position, can it calculate what the length of the hypotenuse is because it's got no height, The A and B of that triangle would be one would be 0, then one would be the hypotenuse length. But I don't know if the math checks out for that. So it's like we need a function to determine the distance in pixels that two objects are. Yeah, so do we do that with a squared plus b squared equals c squared? I don't exactly know. I'm going to write some numbers down. Like if we're 2 pixels down, 5 pixels to the left of our biome, that would make it that square root of 29 would be our hypotenuse. It's like I'm just running these numbers. I'm trying to see if we would get weird numbers if we just use the Pythagorean theorem. Now I guess the question is, I don't know how to do a square root on this thing. (29) square root 5.3 pixels away, which seems to be right for that. But if we're, we just need to calculate each point into a positive number, and then calculate for the c. But if our y's are a line, then our b position would be 5 pixels away. Our a side of the triangle would be 0. So 0 squared is 0. No, 0 squared is 1. Right? 0 to the 0th power would be 1. 0 to the 2th power is just 0. Plus 25, and then you do root 25, which is 5. So yes, when the y's are equal, the Pythagorean theorem still gives us the proper hypotenuse value, which we can then set to be our tween between 0 and 1, however we see fit. That just depends on our biome placement. So yeah, maybe it's like I want here, like I'm trying to think of what I want from my code. Like I want to be able to say that a sound gets set to a value, which is the tween. So it's like the sound, I say sound colon set volume, and then pass it in the parameter to be a biome field, which is set to a tween value based on the hypotenuse of the relationship of our player and the biome positions. And then it updates that tween value based on its x and y position, and each biome is then set volumed to the tween value somewhere between 0 and 1. And depending how many biome locations there are and how far we set them and everything, and what we allow the player movement to be, will determine the overall potential of mix for the different sounds. But we need to be really careful in placing the biomes, placing appropriate movement that makes it able to kind of compose a little mix. If they don't interact, in the right circles, then you can't blend certain sounds, and I kind of want you to kind of blend between the different biomes and really see the weather, right? Because we're trying to go for weather for this code jam. So it'd be like cool to just display some different weather particle effects or different weather sounds based on whatever biome you're kind of standing in the overworld. So I guess if right now we have a mountain biome, a forest, a water, a summer biome, we need to give our instantiation of player a value, give it a variable in which it can store a tween value for the corresponding biome. So it's like we need a function that you give to the player, or you say the player, then you run this function called get biome tween or whatever, and then it goes through all the biomes and it assigns the appropriate tween value based on its exposition for its distance compared to each different biome. So the code is going to need to kind of reflect that, because I need the stored tween values depending on the player's location, so it makes sense to kind of link those fields into the player init function, because there's only be one player. So we kind of bake in those tween values based on its x and y position to appropriate biome fields, which are a number between 0 and 1, and then we calculate that using the Pythagorean theorem, and then we have to like cycle through every biome, right? It's like in the update function, self dot mountain biome gets whatever the player.1 : get tween value mountain biome parameter that takes in a biome, and a biome is going to have to be another class. Since we have multiple biomes of this, we can say a biome is an object that has a sound file that's playable. It sets it to looping or whatever, and then it sets its volume based on another parameter, which is, okay. It's hard to, the more you can kind of figure out what the code needs to look like beforehand, kind of better off. Because it's so abstract, it's hard to imagine what you need more than a couple steps ahead, at least as a beginner. So I'm trying to cover my bases here. But I think it's fair to say that we need a biome class, and then we need to have player instantiation gets the player instantiation gets tween value each biome. That's the ultimate use case, because we need to say that the sound that is playing is determined on these tween values for the biome. So each biome field needs to get populated with an x and a y so that we can run the Pythagorean theorem to figure out the distance between 2 points. Use Pythagorean theorem to calculate distance. Now that needs a player dot player.x and player.y, or it just needs a player object really, which will have those two things, and then it needs a biome object, which also has an x and y. Because all we need to do to calculate the hypotenuse is just a player object and a biome object, because each of those objects will have 2 points, and then we can use the theorem on those 2 points. So the pseudocode for this is going to look like, you know, we need a biome class so that we can assign a different biome as a value, as a tween value, and we get that tween value from calculating the distance and then dividing. Shoot, how do we do that? Because, like, let's say our C is 10, but does that mean 10 is the distance of our 0, or does that make any sense? It's like we need a threshold to set what 0 would be. Like where is the fade 0 in relation to the mix? Because that's the point at which we need to interpolate the Does that make any sense? So like we need to play the biome from 0 to 1 based on the X position. But if we're doing it just through calculating the C, that assumes wherever we spawn will be completely quiet to the biome, because that would be 0, but that's not necessarily the case. We want to be able to move the position of the 0 point in the mix. So like maybe our character is over, like you can't, it's hard to illustrate this. Let me try to explain something. I think this will help me kind of figure out how to pull this off. So we're just looking for a place to draw. Now, yeah, so let's imagine a mountain biome that we're saying is right there in the game. Now, there's, let's say, a ladder right here. Okay, to get up to this mountain biome. Now we have a new layer. It's a character, and here's our character. So currently, if we just use the Pythagorean theorem, we would be saying, hey, set your volume to whatever code we just had, which was checking the X and Y positions, calculating the hypotenuse, you know, calculating this angle, and saying, if you're at this angle, this X and Y position to give this distance, let's say it's 30, I don't freaking know. If it's 30, then when you're right here, it's at 0. But then when you're up here, it's going to be at a perfect 1. So we're going to be taking this value, dividing it by the total, the total point. This is what's hard to kind of explain, is like, do that. You know, we say 30 divided by the length of this, 30, will give us, we need it to be, so this would be the opposite. This would be, hold on. Let me try to visualize this. You know, our tween value is Rx divided by the virtual width. So it's Rx position, whatever Rx position is, divided by the divided by this position. Gosh, how do we do this? Because yeah, we need, so like the idea is we don't want, if we draw the hypotenuse and then we say, hey, since this hypotenuse is however long distance long, we just said it was 30 pixels long for whatever reason. It's 30 pixels long. That means if you're 30 pixels away, you're at the value 0. If you're 0 pixels away, you're at 1. So this is the tween value that gets updated depending on our x position, on our player's x position. That determines our overall volume, right? But the question is, this value that it's calculated on shouldn't necessarily be placed at the player origin point, because let's say there's a different biome, right? There's a different biome over here. Oopsie. There's a different biome over here that we also would be calculating for, right? And it's saying that here's the A and B, and using the A and B comparison, we can calculate the hypotenuse distance, which would be whatever, 60. So then in this scenario, if we just go with that code where it's like wherever the player spawns at to calculate the hypotenuse, then now this will be 0 down here for this channel, and it'll only be 1 if it's over here. But we don't necessarily want, like if we're here at the ladder, this would be already at 10, so you'd already be able to hear this one because it's calculating it based on its starting position. What I'm saying is we want to be able to point little biome markers to be like, hey, your distance to this line, shoot, how do we do that? Yeah, this is why I'm glad I'm drawing it out, because it's like I want to be able to say, hey, here's the hypotenuse, and here is where we want it to be 0, and here's where we want it to be 1, instead of this bigger angle. So like, you know, if our player's here, this would still be 0, instead of it getting louder based on this origin point. So we need to tether the calculation not to the current player's like X position, but we need to choose. See, and this is where it gets hard, because it's like, how do we, it's like we have to check. Okay, I think I know. It's like, I mean, I know how to kind of imagine it, but I don't know how to execute it. So if our character, let's say, is right here, so if our character's right here, the game needs to do a couple things. If our character's right here, it needs to check what all the biomes distance tween value threshold is, or whatever, right? So wherever we choose to put whatever we call this, which let's call it biome biomarker almost. We call this a biomarker. Then we say the biomarker's hypotenuse leg is the length at which the tween values are determined for the player's hypotenuse leg, meaning we need to have a new value based on our current relation to that biome point, not the biome marker, but the biome point, so that we can run the calculation on this, saying, hey, this is 28 long, when the biome marker is set to be 30 as a distance, being the 0 position of the tween value. So this 28 needs to be, 28 over 30, but inverted or whatever, so that we need, it needs to be 2 out of 30 represented out of 10th, which is 0.6 or whatever, I guess. But we do need these two values to compare. We need like a threshold of distance to be set for determining whether a tween value is either 0 or 1. And then we need the current position that compares it and sets the tween value based on its current hypotenuse. And then we need to say it like, if the player's position is greater than the biome's hypotenuse leg threshold, if it's greater than that, you're setting your volume to that channel to be 1 because you can't hear it. You're too far. So does that kind of illustrate the problems here? But I do think this is the way to go. Instead of doing this calculation based on this one point, we want to be able to give this biome marker value, and depending on what the biome overworld is going to look like, determines where to place this to make it make the most sense. Because for the windy biome up here in the mountains, maybe it makes sense to have the biome marker right here at the base of the ladder, so that if the player goes along the X here, this will be 0, because this will be 0 on the windy biome because it never gets closer than the biome hypotenuse, which we can set to be at the bottom of the stairs here. Then as soon as you climb the stairs, it starts turning up that volume because your hypotenuse leg's getting shorter and shorter and shorter. So depending on the overlay of the biomes and stuff determines where we place this kind of biome marker to kind of set the distance. If that makes any sense. So we got to translate all these ideas into code. And the biggest takeaway is we need to set a biome marker to determine the distance that sets our tween value. And then we need to cycle through our player's position on every biome and checking to see if it's under the threshold of the Y position of any given biome, and then if so, it needs to set its volume on the corresponding audio track to be the appropriate tween value based on our current Y position, or our current X and Y position, but as relative our hypotenuse compared to our biome, our actual biome location. So we need a actual biome location for like a little biome to be, it's going to be a point that if your player's X and Y is at, that'll be 100% loudness, right? It's the first point of the biome. And then we need the biome marker to be the 0. Okay. What are you doing, man? Okay, so I'm gonna give us, I know we need a new biome. So I'm gonna put it here in dependencies. File, new file. Biome with a capital gets a class with curly braces because it's a class object. And I'm gonna actually, before I do this, I'm gonna call this biome.lua and save it in our dependencies. Then I'm gonna put that. Then I'm gonna put in our dependencies that we're requiring our biome class, which can go with the player class, I guess. And it's in dependencies, but it's just called biome, so it's in the source folder, in our dependencies folder. It's called biome.lua. Now, our biome class, there is 3 functions for our class. One is the init, which we will give all of its appropriate values. There is the update function. Which takes in delta time. And there's a render function that we need to be able to call. It does all the drawing. Now, what does this need? It needs an X and a Y. I guess we can set its width and a height to be 1, like it's just 1 pixel. Or we could do a square or whatever. I feel like 1 pixel is probably fine enough. Because we're just trying to compare it to a point. It's just a point, really. We need an X and a Y. And then we need it's like how do we determine when to play the song, when to so I guess this game is kind of like all tracks are playing at once, but their mix might be set volume to 0 depending on the current player's X and Y position. So where do we call the function set volume on our sound playable? I guess is the question. And it would be something, it might be in our play state where we say if players X, is, gosh, how do we do this? No, I think we need to set it. We need to set the volume for each biome every single frame in the play state. We just say, hey, biome.mountains gets whatever your mountain tween value is, and it gets the forest biome and whatever that's tween value is every frame. It sets it appropriately there in the play state loop. So we just need to be able to encapsulate a sound. So we don't need to necessarily, since the sound is in a global table, we don't need to encapsulate the sound into our biome class. We just need to say set volume to a function that takes in our player's current X and Y and the corresponding biome and then it spits out a tween value that yeah, so if the tween value, gosh, it's so hard to visualize this. If the tween value is stored in the object itself, then our hypotenuse and our, yeah, shoot. So I'm trying to say our biome objects are going to be holding the tween value, meaning our function to return the corresponding tween value needs to be in our biome update function. So yeah, we can update for our corresponding tween value that we can then set our volume to in the play state game loop. So we need to determine our tween value and function for Pythagorean theorem here in this biome class, because we're going to be running, it's like in our play state we need to say for every biome and biome update said biome objects, and then it'll run through, supplement our current x position, calculate all of our hypotenuse angles, and set all of our tween values for all our biomes all at once, and assign it and do that every single frame. And then we just play the sound mix according to our tween values. So that means it's almost like if our biome, no, hold on. It's hard to imagine what our biome class looks like, because I'm not exactly sure if we just need to give it a name. No, it needs its own. It's like I need to write out more code to kind of figure out how it plays together. So it's like we need to say this is our clamping then this is a test, like test between values for left and right. So that proved that we could update the set volume name. So it's like we need, how do we say this? If we have, the player gets an object called biomes, and biomes is a table of all of our biome objects that we call. So we say, hey, there's a mountain biome, and it's X and Y position. And then it also needs its, what I call it, biome marker. So it needs a marker to determine the closest distance to start playing our fade. And then it needs, I guess it doesn't need it. We'll just say this takes in the player variable or whatever. Our player's X. So if this is a table of different biomes, we would say there's also a forest or whatever. So the idea is if we have a table of all these objects, we can then say for biome in biomes, do, is that how it goes? For key in value. Gosh, we're like, we had done this recently. I'm just like not really 100%. Syntax, love 2D or table list. How do I say that? How do you iterate through list? I know we do it in our Joust code. You know, we say in our play state, maybe we render multiple things. No, we don't. Maybe in our ostrich class, player class. I don't know where I say this. I'm trying to just look at how you iterate through a table in Love 2D. So maybe it's in the collision for the platforms? I don't know. No? Yeah, where do we do that? Where would we have used the iterating through the tables? On the function for collision, on, yeah, all of our stuff. Like here. Pairs, that's what it is, gosh. So you say for key, comma, index in pairs, and then give a list of pairs or a table. Then it would be the index and the value. So here we would say for biomes, so for index value in pairs self biomes, do something, and that something that you're going to do is you're going to take the current, you're going to see in this needs to be, I guess if this is a local variable, what do we do? We need to say for do this. Basically saying for every biome list, we want to update our tween values. But how do we do that? We say self.x or self. Gosh, what do? We need to run a function on our current biome. So like biomes with an S like this is the value of, how do we do this? Of each biome in our biomes. I sound like a crazy person. we're trying to say that biome's tween. So how do we do that? So we need to say something like, God, what do we do? It's like we need to go through each biome and change every biome's tween value appropriate to our current player X. So we need to run a function. Yeah, we need to run a function saying like get tween values, and so this would run get tween values on every object in this list, and we populate this list with every biome we have, and we say run a function on each of those values to get the tween values, and then it's like we need to assign that into, we need to assign that value. What do we even say? It's going to be, it's like we need to, how do we do this, man? We say go, oh, yeah. Yeah, what does this look like? It's almost like I need to figure out getting it working for just one biome for now. Testing it, making sure I get it right, and then I need to abstract it out and say, hey, do this for all the biomes, update all the tween values. Because I think I'm getting caught up in the scale of it, trying to make it so that every biome, so that the biome list we have has every biome and every hypotenuse value, and needs to set every tween value on every single frame, which we don't even have positions or markers for most of these biomes yet. So let's say, you know, let's just start pared down at one biome. So we'll need to choose an X position, a Y position. So like, let's just say that we have a variable called mountain that we're going to store a biome called mountain in. Now we've got this many parameters, but we need a couple more useful things. So it takes in a name. Is that how? Can we do that? Send a string like that? It's just the name of the parameter, right? I don't know how to tell that with these kind of dynamically typed languages. I don't know how to specify that that's a name. Although in our, not our ostrich class, but in our platform class, we give it just a name, set it to self.name, and then we print that name out as a string. So since it's a weak typed language, I guess we can get away with that. We say self.name gets the name parameter, which it will know is a string because we pass it in a string as an argument. Our self.x is our x parameter. Our self.y is our y parameter. And our self.marker gets our marker. See, and marker might need to be, marker might need to be an object too. Marker needs to be an x and a y. Because remember our thing here, this marker right here to determine the 0 and the 1 of our mix has is a point. So it's 2 values. So we might need a marker object as well. Oh. Oopsie. Okay, shit. This is trickier than I was thinking it was going to be. But we need marker to be marker x, marker y are the 2 parameters given. And it's like we need a marker object made for the biomes, specific to the biomes. Yeah, so the init function needs all the proper arguments right off the bat, like its point, its marker point, its name, okay, then, okay, so marker will be a object, I think, because it would be nice to be able to do marker.x, marker.y, and then we can just say marker instantiation gets, well, we would say, you know, mountain marker gets an instantiation object of marker class with 2 values as arguments, which are just its x and y position, but set to the fields named appropriately, so that we can say biome gets instantiated at, we would say mountain biome or whatever gets instantiated at mountain marker x, mountain marker y, plus whatever x and y is for the biome placement. Gosh, I'm feeling a little crazy. You guys think we're gonna be able, I mean, we've only got 6 days left of this. If I can get just soundscapes playing on the overworld, it would be really cool. With the mix of the distance, right? That would be cool. And then it'd be cool if we can get that far. It'd be really cool to get also a sort of adaptive particle simulator based on the closeness of the biomarkers as well. Like desert might have sand particles, mountain might have wind particles, forest might have leaf particles, snow particles, something like that. Or getting close to a water fountain or walking under a waterfall gives you water particles. Does that count as weather? Maybe like, you know, a sun flare in the summer desert as a sort of weather. That would be cool. That would be cool. Yeah, I'm gonna have to work on this more tomorrow. I'm not gonna figure out the biomes and markers just right now. But we can at least make a commit saying that we're gonna add everything with a message saying started to create biome and biome class. Yeah, start to create biome class. And get P to our origin main. Okay. So tomorrow we're going to be fleshing out our biome class. Fleshing out one biome with, we'll do the mountain first, I guess. It'll have a name, mountain. It'll have an X and a Y, and then it'll also have a marker X and a marker Y that it's at the bottom of the ladder or something like that. And then yeah, I'm realizing how ambitious this is, trying to build it. But it's a great exercise. If we can get something out, yeah, whatever. I'm talking in circles now, but yeah, I've got the idea. I think we can pull it off. It's just going to take some more finesse. We'll take it one biome at a time. Once we can get the biome working, then we can worry about scaling it and iterating over many biomes, doing it potentially with multiple sounds at once. And then we have to get working on art, sound design, and particle effects, all in good time. But thanks for watching. See you tomorrow.